Fine. In the last lecture, we have seen the queue and its operation. Actually, and what we have seen is queue is a linear data structure which is there with the analogy of our normal day-to-day encountered queue, in which the first person is going to be served first and is going to be exited first. So the difference between a stack and a queue is prominently stack has only one end from which we can insert and delete the elements, whereas queue has two ends. From one end, the elements will be inserted, that is called as rear, and from another end, the elements will be exited or will be taken out, that is called as front. So queue is dealing with two different pointers, rather we'll say, that will point to a particular variable. Front will point to the variable which is at the front or at the first element of the queue, which is need to be served first, and will it is going to exit or removed from the queue first. And another way we have is rear, which will be pointing to the last element in the queue. And if some new element is inserted, the rear will be shifted to that new element because it will become the next to last of the queue. So yesterday we have seen the enqueue, dequeue functions also, and the working of queue also we have seen. So what things we need to keep in mind are, if I am designing a queue, there are two operations which are to be performed, insertion and deletion. While insertion, I need to check that if whether the queue is full or not. If queue is full, will not be able to add any more elements into that. So such kind of error message you will have to generate if you are writing a program. And if insertion, then it can be the first element to be inserted. It can be second or next element to be inserted. So these two things we'll have to keep in mind. And of course, uh, uh, similar to when we'll delete the elements from queue, same thing is going to happen. So yesterday's assignment was to write a program to illustrate the functions or operations which we perform on the queue, that is enqueue and dequeue, and displaying the queue. I've seen from your class out of 62, 44 assignments are submitted. So I hope you have done those assignments by your own. I want to tell you that if I'm giving an assignment, it is expected that you are doing it by your own, because it is a verification of whatever you have learned in the lectures or in the past session. So try to do the assignment by yourself. And if you need some more time, definitely tell me, or put me a message that you need some more time. But it's don't do in such a way that अरे यार सबमिट करना है तो तुम्हारा क्या प्रोग्राम है, तुम्हारा क्या प्रोग्राम है, just copy paste, change the name, change the font. Don't do that kind of thing. So it is not for bulking up the website, but to confirm whether you have understood or not. And if you have not understood, ask for some more time, ask for the doubts, and try to get it completed. I'm happy that few of the students are continuously sending me the messages regarding the development of this assignment or writing the program or some doubts if they are having. I'm happy, but the quantum is very less. Very few students are doing that. Rest are just attending classes and keeping uh, being in the impression that they have understood everything. So don't do it. Coming back to the assignment which I have given you is this kind of program. You might have written a different kind of program. Here we are defining the size of queue as 5. We are limiting that array to 5. Enqueue, dequeue, and display function, and array of which is named as queue or items is defined. In the main function, we are doing nothing because all the other variables are made as global, so can also be used in all the functions directly. So there are no further declarations in main. We are directly performing the function queue. We are trying to delete item from queue, but it won't be possible. It is going to print your error message because there are no elements entered in the queue right now. We have not initialized that queue. Then we are in performing enqueue operation. That is 1, 2, 3, 4, and 5 elements are inputted, and then we are trying to input the sixth one because of queue full, not going to print that, and then we have a big queue. So these are the three operations which we are going to perform, or which are the functions. So enqueue is taking one value as input and is checking if rear is equal to size minus 1. If it is size minus 1, that means it is full. If it is size is 5 and the rear is at subscript number 4, that is a fifth element. It is going to print the message as queue is full. And if queue is not full, simply what we are doing, if it's an element to which is second or other element, then we are going to add a rear and that element will be initialized to that position. And if it is the first member, we are going to, that means it will be indicated by this, front is equal to minus 1. So it will be given as, it will be initialized to 0. And of course, when front will be minus 1, rear will also be minus 1. But by doing rear plus plus, I can manage that. Here we are initializing front directly. So no need to explain it much. DQ, if front is to minus 1, queue will be said as empty. There are no further elements in the queue. Okay. So if it is not so, we are going to just delete that element, print that element, and front will be manipulated. Okay. Front will be managed. And this condition, what this condition is telling me, when front will be greater than rear, when front is incremented and it becomes greater than rear, that means there are no further elements left in the queue. So both will be initialized to minus 1. Both will be initialized to minus 1. That is initial condition because there are no elements remaining in the queue. So whatever element next will added will be the first element. And this way we can simply display the queue with a formula. So this was a program which I was expecting. The simplest form of this program. You can definitely make it better. If you can definitely make it too complex and having more modules which will have is full condition, is empty condition, that kind of thing. So that you can definitely do. Now coming back to the today's discussion. Let us see this queue. This is a queue. Okay. In which this is the first element. And front is pointing to that. Okay, this is the last element, front is pointing to that. Okay, now in this case, let us say that we are also inserting few more elements. So what will happen? Rear is going to point to the newly inserted element one by one. We can insert the elements one by one. Okay, now at the end, a rear is going to point here. Now in this case, there is no space available in the queue. There is no space available in the queue. Rear is equal to size minus 1. Okay, size is 13 elements are added here. So R is now pointing to the last element, and hence what we are concluding, Q is full. Okay, Q is full. And now let us try, let us see that we are going to insert few elements, delete few elements from that. Let us say that we will be deleting these. We will be deleting these three. Okay, so what will happen? Front will be pointing to this element, then this element, and now it will be pointing to this element. Now 3 becomes the first element of the array and leaving these three spaces free. This 3 spaces free. So this will be the scenario. Okay, right now I'll just add these things also here. 7, 8, 15. So what has happened? R is pointing here. R is suggesting us that it has already reached the last element and no further element can be added. That will be the Q full condition. Okay, that will be the Q condition. Am I right? We are doing this way. Here, rear is equal to size minus 1. That means Q is full. That's what we are saying. So when R is pointing to the last element, that means Q is full. Now I have removed three elements. I have removed three elements, and now if I want to insert one more element, let us say that I wish to insert 20. I want to insert this element. I'll check the Q full condition whether R is equal to size minus 1 or not. If R is equal to size S minus 1, yes, it is true. Right now, R is pointing to the last element of the Q. That means it is going to give me a message Q is full. This is the biggest disadvantage of this data structure. Because Q is not full, we have three empty spaces in the queue. We have three empty spaces in the queue. That is why Q is not full. Still, we have been denied with adding any more elements in the queue. This is the disadvantage of your queue data structure. Are you understanding? Okay. Now, how to overcome this? Have you understood the disadvantage? Even though we have so much of space available, we won't be able to add any more elements because R is pointing to last element. And the spaces are available before front. This is why we won't be able to add any element, and this is a disadvantage of a linear queue, which is not good. So this is little modified, and we are coming to a new concept, not new concept, additional concept called as circular queue. Circular queue is again a linear data structure. It's very simple. Only thing is, what we are going to do, we are going to make the last position connected back to the first position to make it a circle. That means, in this case, what we are going to do, after this, we are going to connect it to the first one. Means R will be incremented by 1 and will point to the first element. So we are going to construct a ring kind of structure. We are going to construct a ring kind of structure, which will be appearing in this way. It will be appearing something in this way. Okay. You consider this as a full strip of an element. Okay. You consider this as a simple strip of an element. Okay. This is logically only represented in this way. This is only logically represented in this way, but it looks actually like this. That means this is a 0th element, first, second, and so on. The elements which are added here is 10, 20, 30, 40, 50. Okay, rest of the elements are. Only thing is, this will become front, this will become rear, and in this case, when I reach rear here, I am going to get it connected back to. So here you can see we are moving from 0, 1, 2, 3, so on, and when we reach R as the size of -1 as the maximum index, I am going to again shift it to 0. It's a circular. So what will happen here? Even if I am removing now, if I am removing 10, front will be pointing here. So even if I am adding 60 here, 70 here, 80 here, and now I am deleting one element, so I can add 90 here. R will be pointing from this position to this position now. Are you understanding? So a circular queue is designed where after the last element we are trying to access the front element, and we'll check if the front first place is a vacant, then we are going to point R there. If it is not vacant, then we cannot add. But if it is vacant, then we can add. So this is also called as a ring buffer. We'll go for the example of it. We'll see this later. Now, if I'm doing only this thing, this is the queue, the same diagram I'm taking. Let us say that we'll insert the initially F will be -1, and so will be R. R will also be -1 initially when there are no elements in the queue. And what is size here? Size is equal to 8, or n will say n as 8. N as 8. N as 8. Okay. So there are F, R, and N. This is the same analogy which we considered in the previous example. Okay. So there are no further changes. Now, if I insert the first element, so again there are same cases. It will be the first element to be inserted. It will be the second or next element to be inserted. It will be the first element to be deleted. Always the first element will be deleted. So let us say that I have inserted 15 as the first element. Okay. So front will be pointing here. Am I right? Front will be initialized to 0. Same case which we did in the past one. Similarly, this will be the first element as well as this will be the last element. So rear will also be pointing here. This is the first case, which is very similar to the queues, whatever we have seen earlier. Okay. So front and rear are initialized to -1, and when the first element is added, both will be incremented by 1 to get the value 0. Both will be pointing to the same element. Now we'll add one more element. Okay. We'll add one more element. It will be 15, 20. So in this case, F will remain same. What happened? R will point here. Okay. I am adding 30. R is going to point here. Here I am adding 46. R is going to point here. So what simply it is working similar way to the previous one. That is, R is incremented by 1, and F remains same if it is second or next element. Okay, if it is second or next element. So that way we can do. That way we can understand. Now next, we'll still add a few more elements. So at this moment, what will be the case? R will be pointing here. R will be pointing to the last. R has attained the maximum size of the circular arrow. Okay. This thing is over. This thing is okay. Okay. So I think you are understanding. And if you are not understanding, put it in the chat box or interrupt me by putting your mic on. That will always be better for you, because without understanding, proceeding further will not be a good practice. Right. So I hope you have understood this. Then one by one, R is added. Now let us say that we are removing 15. Okay, we are removing 15. We are removing 20 also. So what will be the scenario now if we are removing both of them? It will be 30, 46. If I am removing all this, rear will be unchanged. If I am removing 15, the first element F will be pointing here. If I am removing 20, the second element F will be pointing here. So here also it is the same thing. We are doing F plus plus every time we delete one element. Okay. We increment R every time we insert one element. Every time we delete one element, we increment F. The same case which we have done in the past one. Now, what is the difference? In this case, I have these spaces available. R is here. I can increment R by 1 to insert more elements. Okay. In case if I want to insert an element 27 in this queue, it is possible to increment R by 1 and place 27 here because there is a space after R. There is a space after R. Okay. So in how these conditions will be handled, that we are going to see. Okay. So at this point of time, when we have not erased or we have not deleted 15 and 20, when this was a queueful condition, we are simply saying that if R plus plus is equal to F, if R is equal to R plus 1 is equal to F, that means Q is full. Am I right? What we are doing? If R is equal to R plus 1 is equal to F, that means Q is full. So if I am incrementing R further, I am going to point to this particular element. I am going to point to this element, which is F. So I cannot insert any more elements. And if R plus plus is not equal to F, R plus plus is not equal to F, there is a vacancy to input element. So in this case, you see, in this case, when I add R, it will point to the next element, which is not F. So it is possible for me to add an element. How these two things will be handled? Because if I am saying R plus plus, it should become 8. And we don't have the index 8 anywhere. We don't have any index 8 anywhere. So what is the remedy over this? What we do, we calculate R not as R plus 1, but we calculate R as R plus 1 mod, that is percent symbol, mod n. What is the mod function? Can any one of you tell? What is the mod function in C or in programming languages? What is mod function? You can place your answer in the chat box. Anyone? What is a mod function? Or this percent symbol in C? I am waiting for the answer. It returns remainder.
So remainder.
Yes, absolutely right. It returns remainder. When we use a mod function, it returns remainder. Division returns the quotient, and because division will result into 2 outputs. Unlike plus, minus, and multiplication, division will return 2 outputs. One will be quotient, another will be a remainder. Okay. So in this case, see how it works. What is this? 7 plus 1 divided by 8. That's modulo 8. It is 8 for 8 mod x. It is going to return you 0. Okay, it is going to return you 0. And can I see f is at place 0? Right? So at 0th position, I already have pointer f. That means the element is present there. I won't be able to add the element. But when I apply the same case in this matter, what will happen? It is going to return 0, and 0 is free. That's why I can enter it. So R will be now becoming 0. R will be 0 in this case. Are you understanding? R will be 0. Again, I am trying to add an element. Let us say that element to be added is 89. I want to add 89. Is it possible with this formula? Is it possible with this formula? What this formula will return now? R is equal to R plus 1. What is R currently? 0 plus 1 modulo 8. It is going to return you 1 divided by 8. Its remainder is coming out to be 1. So this is a new value of R. So R is 1. And which is not equal to F. So I can add 89 here. Now I wish to add, let us say that 97. What will happen? I want to add 97. In the same case, what will happen? R will be equal to 1 plus 1 divided by 8. Maybe 2 divided by 8, remainder will be 2. R is equal to 2. Okay. R is equal to 2, but it is equal to now F. R is equal to, it is equal to F. So as F is already pointing to that position, that means it is having some element in it, and I cannot add the element any further. And you can visualize that I can add the element only if there is a space. And if Q is full, it is not permitting me. But in the previous case, what was happening? Even though we had space, we were not able to add the elements any further, because we were stuck to the condition that R is equal to size. R has achieved the size index. But in this case, it did not happen. When I removed 15 and 20, I made a space where I can add a few more elements. Okay. So this is a analogy of inserting an element into Q. So this is a formula which you'll have to keep in mind. Okay. R will always be incremented in a fashion that R plus 1 modulo size. In any case, here also you can take that case. Let us say that here I'll do this case. Okay, I am inserting 20 here. That means R need to be incremented, but R will not be incremented by 1, but R will be incremented by R plus 1 divided by N modulus. So what R will become in this case? Initially R is 0 plus 1 divided by N, and its remainder is coming out to be, that is 8. So it is going to be coming out to be 1. So R will be 1. R will be pointing here. And now I can say that Q of R is equal to whatever new value. Is coming. So we are concluding that in circular Q, R not incremented as R plus plus, but it is incremented as R plus 1 modulo N. N is the size of array of the Q, which is represented the Q. Are you understanding this? Have you understood this? What have you done in this case? Is it yes or no? Is it clear? Please be active and prompt at least, or tell. Now we'll just see how we can write a function for this one. Similar will be the case with front. Front will also be implemented in a similar manner. This front is equal to front plus 1. Okay. So it will also be implemented in the similar. So let us write an algorithm for inserting an element in a circular queue. How can we do it? Insertion, that is insert queue. First step will always be check whether queue is full or not. Okay, check is full. If R is equal to max minus 1, max is the size of size of the array. So if it is at minus 1 and front is still equal to 0. So if R has achieved the maximum index and front is still 0, at that time we'll say that queue is full. Or in case front is equal to rear plus 1, then circular queue is full. Rear plus 1 means, again I am repeating that it is not only rear plus 1, but it is a mod function. Fine. And insertion operation is not possible. Okay. If this is not true, we are going for this position. If in this case, what we are going to do, if rear is equal to max minus 1, then set R is equal to 0. Otherwise, increment rear by 1. Okay. If it is not the maximum value, we can simply increment by 1. But if it is the maximum value, we'll have to set it to 0. And front is not equal to 0, that we have already checked. Okay. But as I said, we are not going to increment R by 1, but we are going to increment R in this way. Right? So this is a simple step. Then we can just assign that newly coming data there and check the position of front pointer. If it is minus 1, set it to front, set front actually. Okay, this is the normal practice. If the inserted element is first element, then we are going to. This is, I've just pasted the same thing over here. This should not be insert operation. It's a DQ or delete operation. The circular. Okay. So this way we can let me write this. Here one general thing I want to tell you is Q is the alphabet which never comes without U. Okay, Q cannot be used without U. Any word which is starting with Q or anywhere Q is used, it is going to be supported with Q. And E is the letter which is used maximum in the case of in English alphabet. E is the maximum used alphabet. Okay. This is just a thing because if you might have played Scrabble and all these things. Okay, now when we try to delete some item from the queue, first condition is queue is not empty, that we'll have to check. Okay, if front is minus 1, then queue is empty, we cannot delete any other element. Okay, if it is not so, check for the position of front and rear pointer. Okay, if front is equal to rear, that means there is only one element in the queue. Remove that and set the front and rear to minus 1. Okay. So if front is equal to rear, then there is only one element in the queue, and you just remove it and put front and rear is equal to minus 1. Okay. If not so, then if front is equal to max minus 1, if front is the last element, then we are going to just remove it and set front to 0. This front will again be pointing to the first element. Here we are not doing much about rear. And last thing, if it is the element to be put in between, data will be printed and front will be changed in the similar way we changed rear. Okay, so front is equal to front plus 1 modulo max. Max is size of the array. Okay, this way we are able to delete a element from a. Okay, these are the two algorithms which will use. Now I request you, whatever program you have written yesterday, modify the same program for circular and check whether it is working or not. Circular queue, again, I am repeating that this is just a logical representation of circular. This is a logical representation of a circular queue. In actual case, it is going to be the same as that of an array. For stack also, we are taking a logical representation, but it is also an array. Queue is also an array. Circular queue is also an array. So physically they will be represented as an array. Logically, we are taking care of all this. Fine. So I hope I have made this point clear. Anything need to be repeated, you can please tell me or ask me to repeat. Now last, just a small theoretical concept which I want to just share with you is a priority queue. What is a priority queue? See, what for we are using queue for schedule the job. May it be a CPU job, may it be a memory job, or may it be a resource job. To schedule the jobs, we are making use of queue. So you have one type of queue which is called as priority queue, which is kind of, it has assignment of a priority also along with the element. Okay, so if there is a queue and we have 4 elements. Okay, so it is going to give me the element along with its priority. Okay, let us say that these are few elements. Of course, it is not going to get stored with the element. I am just giving you an analogy of it. If these are the elements, along with that, it is going to give me the priority of it. Let us say that so it will be along with the priority. So at that time, not the element will be seen, the priority of the element will be seen, and that job will be executed first. So in this case, executed first in the sense it is to served first, it is going to exit the queue first. It is going to exit the queue first. So in this case, not 55, but 27 will be the element which will be exiting the queue first. After 27, it will be 72 because it is having a second priority, then the third priority, and the fourth priority. Okay, so 27, 72, 80, and then 55 will be the order of execution. So here, the priority queue is a collection of elements where each element is assigned a priority, a precedence, and the order in which the elements are deleted. Okay, so the priority will be the order in which the elements are deleted. Okay, and that is determined by following rules. The element with higher priority is processed before any element of lower priority. As I said, one will be executed first, no matter what it has in front of it. And if 2 elements have same priority, that are processed according to the order in which they added to the queue. Okay, so this is a priority queue. We are not going to implement it. It is just a theoretical concept which I want you people to know, because sometimes let us say that we are working on computer and suddenly the power goes off. Okay, when the power goes off, the computer shuts down. But computer shuts down, it definitely shuts down abruptly. But when you reboot it, you can find that whichever windows were already you are working on, some windows will definitely be open, will be recovered. MS Word document will be recovered. Internet Explorer will be restored. This kind of thing happens. So at that time, what actually happened in the backend? the computer was doing some jobs, but the higher priority job, that is power interruption, came into picture, and it has to first attend that and neglect all of them. Attending a power interruption means saving the current work immediately with the battery power which is available. Okay, OS is designed in such a way that it will save the currently going work as soon as a power interruption came into picture. So power interruption is the highest priority job which need to be conducted, leaving all the other jobs aside. Okay, so this way a priority queue is maintained. You need not to much bother about it. It's just a theoretical concept you must be knowing. Okay? That's what I wish to tell. So we have seen stack and queue, and we have tried to implement them using arrays. Okay, but in queue or stack also, if I say that the element is removed, actually we are not removing it. See here, when I'm talking about the DQ, I'm just taking that data out and displaying that this is the element which is taken out. This is the element which is deleted. But actually, physically, it remains there. What we do, we just change the pointer. We just change the pointer from that element to the next element so that that will be neglected. We are not accessing that, but it remains there. It doesn't get destroyed. It doesn't get removed from the memory. It doesn't get removed from that queue even. It may be overwritten later. It may be overwritten later, but it remains there. That's the biggest disadvantage of array. What array does? Array consumes the space which is required to it well in advance, and it keeps that space consumed till the program is under execution, or probably after that. So that disadvantage of array is actually creating lot of fragments in the memory and making our memory accessible. Fragment means the unused memory, small unused memory pieces, which are not useful or cannot be used any further. For that purpose, we are going to learn about absolutely new and wonderful array with which we can implement many things by 1D array, 2D array, 3D array. We have a concept of linked list, which will also be helping us at the equal level. Equal level in the sense it is going to help us to be implemented, to implement a stack, to implement a queue, to implement a hash table, to implement other data structures which we are going to learn. Okay, so we are going to see linked list as the concept in the next lecture. That lecture will be very important for you. Now, what I want particularly now, you people, please, I have uploaded which I have used in the lectures till date. If you please go back to the lectures which we conducted till now, through the PPTs which we have used till now, and make sure that you have understood all this thing. So it's just simply proceeding in the syllabus won't help us to understand the syllabus, and ultimately you will find the subject really very difficult. If you have not understood, take your time. Probably tomorrow we have a lecture and then we don't have a lecture. So sorry, tomorrow is a holiday, so tomorrow we don't have a lecture, and probably we'll meet directly on Monday. For section B, we are going to meet directly on Monday. So my request is to use these 4 days to just find out, dig out the concepts which I want to, which you want me to repeat. Okay, who is the CR of this class? Is it Vedant?
Yes, sir.
Vedant. So Vedant, whatever unofficial group you may be having, you people please discuss, and anything to be repeated till now or anything you want to get understood, please tell me. I'll repeat that lecture, because unless until all these things are clear, there is no point in proceeding further in the syllabus. Okay.
Yes,
Now
sir.
we have to go for very tough concepts. They are not tough, but they are little mm, uh, what we can say complex to understand. It channelizes your problem solving abilities or thinking ability. So if you want to get them channeled, little over little oiling should be done. So whatever we have done till now is just a oiling. So make sure that it is oiled properly so that it will be functioning properly in the next part of your syllabus. Okay. So Vedant, by I expect Thursday or Friday, you will drop me a message saying that, sir, these are the points which we want you to repeat, or at least you will post a message, sir, everything is clear to everyone in the class, so there is no repetition. We can proceed with the syllabus. That you
So
will
till
confirm me.
next week or these weeks?
Till Friday, you just tell me, no, what topics you want to discuss.
Okay,
That
sir.
is okay. No? 3 days is enough for everyone to understand what is not clear. And in next week, we will repeat all those things. है ना? तो अच्छा
Okay, sir.
रहेगा हमारे लिए. ठीक है, क्योंकि प्रैक्टिकल्स भी अभी कॉम्प्लेक्स होते जाएंगे धीरे धीरे, और सिलेबस भी थोड़ा कॉम्प्लेक्स होते जाएगा. तो मैं चाहता हूँ कि ये सब्जेक्ट सही तरीके से आपको क्लियर हो, क्योंकि दिस इज अ बैकबोन ऑफ योर कंप्यूटर इंजीनियर. Everywhere you are going to use this one. Okay. So this is all from my side today. If you wish to ask anything, you can ask. Stay back and ask. Others can leave the class.